Hello, good evening. Good evening.
Hello, Ahmed.
Hi, Brand. Hi, Troy.
Hi.
So, are you ready with did you work with the task from last time? Did you work on the task?
Yes, yes. I set it up in Heidi SQL and MariaDB. I can show you if you want.
Yeah, you can choose.
Okay, so I'll share my screen. Just a second. This one. I hope you can see something.
Yeah, I can see.
Okay. It's set up in a virtual machine. This is my database design. And then I put in the data. And then I have done 7 queries. I will load them just a second. So this is the first query.
Yeah.
So I can let it run and get this result. And for the second question, this is the second query. You can get it run and get this result.
Yeah.
And this was the third question. This result.
Mm-hmm.
Fourth question. This result. Even the fifth question. This one. Six. This result.
Yeah, I see.
And this is ordered by account type.
Mm-hmm.
This seventh is ordered by account type, and our balance descending. It looks like this.
Okay, this is number 7, right?
Yeah.
Okay.
This is account type and our balance
Yeah,
descending.
or ordering by two parameters. Yeah.
Yeah. Yeah. Okay.
Yeah. Thank you so much.
Yeah. Okay. So I will stop sharing again.
Yeah.
Okay.
Okay,
Still,
Tarek, if you wanted to present us something, or do you have the same? Like, do you have the same solution?
wow, he got hacked.
Ah, okay. So just
You can read it in the chat.
okay.
Wow.
Yeah. I found it now. Ah, okay. No problem. I mean, the main idea is that like we every time we just need to to share what you have reached and so on. Okay. So I hope you can see my screen. Just a second.
Right
Uh,
now, not.
yeah, I'm sharing. I'm sharing. Just a second.
Okay.
Okay, so I think now slide. I think you can see something.
Now it's coming up. Yes. Now it's green.
Okay, so green arrow is good.
Green is good, like at the traffic lights.
Yeah. Okay, so today database modeling, database systems. Today we are going through unit 2 and unit 3 and unit 4.
Mhm.
Conception and modeling of relation database, creating relational database. Today's it will not be like the last time. Last time we had like many examples and so on. Today it will be more conceptual. So we are giving the concepts of modeling and designing the database. This is something very important. As I told you, it's not easy task for anyone just to start and create databases and say, okay, hey, I have like the best database for the company. It requires a lot of experience, a lot of thinking, a lot of designing. We have two concepts very important. Something called um, the logical design and the physical design. Logical design, yeah, exactly. Unit four. But I mean now we are getting unit three and unit four in the same lecture. Okay, so logical design, it's about the fundamentals and the design of the database and the relations and how the database from logical perspective. But physical design, it's about the physical data, the data of the user or the requirements from the customers or from your application, and this is how to apply the design. It's exactly like when you make like logical design for a house. It's just a drawing. You just draw something on paper. And the physical design, it means you start to build the things together. You start to build the first floor, second floor, and so on. So this is the difference between logical and the physical. So let's go through also the every time we have study goals. Study goals for today: design a database using an ERD, entity relationship diagrams, model relationships among tables within an ERD, the relationships and the connection between or among the tables. Normalize the tables in a database. Normalizing concept will be will be today explained. So we will explain today normalization, and it's very important to understand the normalization as I told you before. So I also added here for today one animation video to show you what is the different levels of animation, sorry, different levels of normalization, and how is it important to improve the your database and make it faster without duplications. Okay, so let's go through first one today, why it's necessary to design a database before starting implementation. So just imagine if you just start to build a house without having a design. It's possible. It's possible just to start to building in the physical way without having a drawing and a plan, but it will cost you a lot. What if you have what if you have a mistake? What if your plan is not like in the physical real life real implementation? You found something missing. You found like the space for like sleeping room is like smaller or larger than you wanted, or like the you found the like the kitchen is like larger than you wanted. Like this kind of concepts, it's hard. It's possible to fix, but you have it will cost you a lot of money. This kind of cost that you need to just revamp or just rebuild. This is the same story in database. If we have right design from the beginning, and this design it gives us like the connections at what we need and what we require, and then we see in this design it's already covering all the customer requirements, then we can continue with testing that in physical modeling. So that's why it's very important to start, and why it's necessary to give you like the feeling, to give you the like a better idea what you really you need for your database. One also important thing, like if you plan your for your database design in the right way, also it will give you like the optimal, and also with low without redundancy in data, and also give you like better database. So is data redundancy desired or undesired feature in a relational database? We in databases we try to make the redundancy to minimum. We try to because it takes like memory, it makes also the database connection, and when you query for data, or when you search for data, or you retrieve data, or edit, or you wanted to do any transactions in data, it will take more time. So in the optimal design, that we decrease redundancy. And for must a primary key be defined in each table in a relational database, we it's always, as we mentioned also in the first lecture, it's always great that you start to plan for to figure out which column is your primary key. And it's very important to define that for relational database, because through that you can do, as you saw in like examples from last time, how we used this like column to get data, retrieve data, and so on. So we watch this video
Conception
together.
and modeling of relational databases. Designing and developing information management systems or databases is an innovative process that must follow a rigorous methodology to ensure that the database is issue-free. Databases are complex engineering systems that are omnipresent in our modern lives. Databases interact extensively with our daily lives in almost every aspect, from healthcare, traffic control, and economic analysis to schools, hobbies, and social media. The complexity of the fields that depend on databases as central control element obliges us to deal with databases exactly as an engineering project, following efficient proved processes and methodologies. As in any engineering area, when approaching database development, we need to start with a design or a blueprint. In the world of databases, we call this blueprint an entity relationship diagram, or ERD. An ERD is a diagram that models the database, the tables, and the constraints. As in any engineering blueprint, ERDs can represent different modeling levels and differ in the details they include. Along with ERDs, we need to be sure of the integrity of the database. One way to do this in relational databases is to ensure the normality of the tables in the database, which means that we want to be sure that the tables are normalized. In other words, we need to put the tables of the database in an accepted normal form. Most often, we would accept a database in 3NF, BCNF, and or 4NF.
This is usually you see something like this for about ERD. How to draw ERD, how to start drawing these connections between all tables you have. You can create tables first. Still Torlak, it's coming, still coming. I told you I added video for normalization. I will present it to you a bit later, but it's coming still. Okay, so how to build this relationships between the tables? You can use applications like Visio, like eDraw Max. There are plenty of applications you can use to work on this ERDs. work on this design, how to make these connections, how to draw all the tables, and start building your logical design in the application, so you can know what is the primary key here. This is like mark of primary key in ERD diagrams, and also the communication or the relationships between this table and the other table, and this kind of information. And here it's just showing you, like, if you wanted to build or just design apartment, you start with some drawing like this to define, okay, here is the kitchen, here is the here is the bedroom, here is the sleeping room, and so on, like living room and so on. Like it's giving you like what is the size of every room, and the connection between rooms and so on. Usually we use this kind of attributes for every for every entities. We have like attribute one as the primary key, and attribute two, attribute three, and we start to define these attributes in our also graphical notations. It help us, or it also helps the database developer. If you just give them the design, your design, they can build on that. They can build the full database based on your this drawings. If they have just this drawing, like the attributes, and which attribute is the primary key, and the attributes about like age, about address, and this kind of attribute, you from that you can take it to the physical level. We and now we also one concept that's very important also in ERDs, on the cardinalities. It's this something called, we have maximum cardinalities. Cardinalities, it's something just uh, fundamentals, giving us fundamentals of the relationships between the entities. So it clarifies or declare clarifies the relationships between the entities we have. So we have two types: either maximum cardinalities. Maximum cardinalities can be one-to-one relationship. We talked about that already. One-to-one, one-to-many, many-to-many. This is as concept. Or we have something called minimum. It's called minimum cardinalities. It means here that this relationship is mandatory or optional. So mandatory, it means it must be there, or optional, it could be or not to be. Like as you see here, like for this one, like we have relationships between entities, and then we present like if this something, like as you see here, like this simple here, or also this samples between the relationship. It means here it's like kind of like this relationship between the entity one and entity two. What kind of relationship? So we need to figure out first, like if this maximum cardinalities, it means it's beginning from at least you have one-to-one relationship, or one to many, or many to many, but at least for the maximum cardinalities you have one to one. But for minimum cardinalities, you could have the relationship or not. Mandatory, it means like, is this relationship mandatory or not? This can be clarified better in this video, like in example.
Minimum and maximum cardinalities. Relationships among tables are characterized by several properties, of which the minimum and maximum cardinalities are among the most significant. In relational databases, data is distributed over several tables, and there are relationships created among these tables. In order to preserve the data integrity within the database, we need to specify some characteristics of each relationship in the database. Some of these characteristics are required and some are not, even though it is a good practice not to omit any of the characteristics. For example, some designers might choose not to name one or more relationships for one reason or another. However, it is imperative to specify the cardinalities of the relationships. There are two types of cardinalities, maximum cardinalities and minimum cardinalities. Maximum cardinalities define the maximum number of instances that can participate in a relationship. The values of the maximum cardinality might be either one or many. On the other hand, minimum cardinality is the minimum number of instances that must participate in a relationship. The values of the minimum cardinality could be either optional or mandatory. Here, for example, the serves relationship is a one-to-many optional mandatory relationship. This means that regarding the maximum cardinality, one representative can be related to many records in the customer rep table. However, each record in customer rep is related to only one record in rep. On the other hand, regarding the minimum cardinality, both sides of the relationship are optional, which means that we might have representatives in rep that do not match any record in customer rep, and we might have records in customer rep that do not match any representative in rep. The served by relationship is a one-to-many mandatory relationship.
So database normalization. We are going now to next topic, normalization. Okay, so you have still Tor like a question. In a relationship, what is the difference between Martin UML chain notation? This is different schools for drawing. Like we have different like this one used like for the entity, like one use one shape and the other one use another shape, like one using for entity this how it's called. It's, I can show you. We go back here. Like if you have attributes, you can draw them like in circle. So you can present like it's up to you which school you want to follow in UML diagrams. When you wanted to design, you can use Martin or Chin. It's up to you. But when you define the school, it's very important to talk to your colleagues in the company. Okay, what kind, when you join company as database developer, it's very important to say, okay, what kind of design you follow, like this school or that school. So to have the same like same design, same style. So you can't like use Chen and the other one use Martin. So it will not be like there is no consistency between your work and their work. So it's very important to use the same schematic for both of them. The second question: how is the schematic representation? Could you elaborate? What do you mean? schematic representation, as I told you, like this is like kind of like as you see here, this is schematic representation. You do some drawing to take it from logical design to physical design. Okay, I see. I understand what you mean. This is, as I told you, this is just a schematic design or a schematic representation. We have the same word for also in engineering. In engineering, yeah, I can tell you, okay, please do schematic or send me your schematic. Okay, so it's just about the design you are working on, how you present your work in a schematic way, and then you take it from schematic or logical design to physical one. What I just want you to understand what means non-relational or relational relationship. That's the question about this theme. So okay, so relational relationship, it means you have connection or main relation. You mean from what I'm explaining here in the I can't get your point. You mean here in the like here in presentation or what? If you are talking about just the video we have been watching, okay, in ERD diagrams, Okay, so it means it's like having if it's relational or non-relational. If it's relational, it means there is uh, in the cardinality here, as we have been talking, you have maximum cardinality. It means you have at least you have one-to-one relationship. As we watched in the video, between like what the customer could have representative or not. So in this case, there is no relationship. But if the like in the other one, like if there is maximum cardinality, in this case you have at least one-to-one relationship. So in this case you have like you have like a relationship, or maybe optional, or maybe not there, like if the relationship is mandatory or not. Non-relationship is optional. Yeah, yeah. So this is the topic you wanted to understand better, normalization. Let's go through normalization and understand what normalization is. The database normalization is a database design. So it's a design principle for organizing data in an organized and consistent way. This is the target. And it helps you avoid redundancy and maintain the integrity of the database. It also helps you eliminate desirable characteristics associated with insertion, deletion, and updating. The most important one also about normalization, it decreases complexity, eliminate duplications, and organize data in a consistent way. In normalization, the data is divided into, this is how we do normalization, and in the animation video you will see that the data is divided into several tables instead of having one table containing all data. So we just decompose the table into into several tables linked together with relationships. Here is the video.
With the help of normalization, we can organize this data and also reduce the redundant data. Hey guys, this is Pratik from Edureka, and I've a session. I'll explain everything that is related to normalization with simple examples that are easy to remember. Firstly, let's look at the agenda for today's session. So we're going to start off with understanding normalization, and moving further, we shall look at various types of normalization. And those are first normal form, second normal form, third normal form, and voice-code normal form. I hope you guys are clear with the agenda. But before moving further, if you haven't subscribed to our channel, then do. The first topic in today's session is, what is normalization? Database normalization is a technique of organizing the data in the database. It is a systematic approach of decomposing tables to eliminate data redundancy. It is a multi-step process that puts data into tabular form, removing the duplicated data from its relational tables. On the screen, we just saw that the table is getting decomposed into two smaller tables. Is it really necessary to normalize the table that is present on the database? Well, every table in the database has to be in the normal form. So normalization is used mainly for two purposes. So the first one is, it is used to eliminate repeated data. Having repeated data in the system not only makes the process slow, but will cause trouble during the later part of transactions. And second one is, to ensure the data dependencies make some logical sense. Yes, usually the data is stored in database with certain logic. Huge data sets without any purpose are completely waste. It's like having an abundant resource without any application. The data that we have should make some logical sense. Normalization came into existence because of the problems that occurred on data. Now, let's look at those problems. And these are known as data anomalies. If a table is not properly normalized and has data redundancy, then it will not only eat up the extra memory space, but will also make it difficult to handle and update the database. Let's look at the first anomaly, that is insertion anomaly. Suppose for a new position in a company, Mr. Rakshit is selected, but the department has not been allotted for him. In that case, if we want to update his information to the database, we need to set the department information as null. Similarly, if we have to insert data of 1,000 employees who are in similar situation, then the department information will be repeated for all those 1,000 employees. This scenario is a classical example of insertion anomalies. The next one is update anomaly. What if Mr. Rakshit leaves the company or is no longer the head of the marketing department? In that case, all the employee records will have to be updated. And if by mistake we miss any record, it will lead to data inconsistency. This is nothing but updation anomaly. And the final one is deletion anomaly. In our employee table, two different pieces of information are kept together. That is, employee information and department information. Hence, at the end of financial year, if employee records are deleted, we will also lose the department information. This is nothing but deletion anomaly. So these were some of the problems that occurred while managing the data. To eliminate all these anomalies, normalization came into existence. There are many normal forms which are still under development, but let's focus on the very basic and the essential ones only. So we will be talking about first normal form, second normal form, third normal form, and finally end this session with voice code normal form. So without wasting further time, let's proceed to first normal form. In first normal form, we tackle the problem of atomicity. Here, atomicity means values in the table should not be further divided. In simple terms, a single cell cannot hold multiple values. If a table contains a composite or multi-valued attributes, it violates the first normal form. So the following functions will be performed in first normal form. First one is, it removes repeating groups from the table. And next, it creates a separate table for each set of related data. And finally, it identifies each set of related data with a primary key. To understand this in a better way, let's look at the given table. In the employee table, we have employee ID, employee name, phone number, and salary as columns. We can clearly see that the phone number column has two values. Thus, it violates the first normal form. Now, if we apply the first normal form to the above table, we get the following result. In this table, each and every row is distinct. That is, no cell has multiple values. The table has achieved atomicity. First normal form is simple and can be easily identified. In the table, we can clearly see there is no multiple values in each and every column. Thus, the first normal form is achieved. Now, let's move to second normal form. Second normal form was originally defined by E.F. Cord in 1971. A table is said to be in second normal form only when it fulfills the following condition. The first condition is it has to be in first normal form. And the second one is the table also should not contain partial dependency. Here, partial dependency means the proper subset of a candidate key determines a non-prime attribute. So what is a non-prime attribute? Let's understand this in a simple way. Attributes that form a candidate key in a table are called prime attributes, and the rest of the attributes of the relation are non-prime. For a table, prime attributes can be like employee ID and department ID, and the non-prime attributes can be like office location. To understand second normal form, let's consider this table. This table has a composite primary key, that is, employee ID and department ID makes the primary key. The non-key attribute is office location. In this case, office location only depends on department ID, which is only the part of primary key. Therefore, this table does not satisfy the second normal form. So what to do in such scenario? The answer is simple. Split the table accordingly. To bring this table to second normal form, we need to break the table into two parts, which will give the following tables. The first table has employee ID and department ID as columns. The second one has department ID and office location as columns. As you can see, we have removed the partial functional dependency that we initially had. Now, in the table, the column office location is fully dependent on the primary key of that table, which is nothing but department ID. I hope you have understood second normal form. Now that we have learned first normal form and second normal form, let's head to the next part of this normalization. Next topic is third normal form. Third normal form is a normal form that is used in normalizing the table to reduce the duplication of data and ensure referential integrity. The following condition has to be met by the table to be in third normal form. And the first condition is the table has to be in second normal form. And the second condition is no non-prime attribute is transitively dependent on any non-prime attribute which depends on other non-prime attributes. I know it's a bit confusing, so let me make it simple for you. It's like if C is dependent on B and in turn B is dependent on A, then transitively C is dependent on A. This should not happen in third normal form. All the non-prime attributes must depend only on the prime attributes. So these are the two necessary conditions that needs to be attained. So why was third normal form designed? Firstly, to eliminate undesirable data anomalies. Next one is to reduce the need for restructuring over time. Finally, to make the data model more informative. Since we have understood the third normal form, let's look at the example table. In the above table, student ID determines subject ID and subject ID determines subject. Therefore, student ID determines subject via subject ID. This implies that we have transitive functional dependency. And this table does not satisfy the third normal form.
What do you think it should be removed from this table? Which columns here not based on the student ID? We need here to just remove columns and put it like in separated table, a new table. Rand, you wanted to say something?
I'm thinking about this is a little complex. I have to think about, but I would choose student ID as primary key.
It's not. I mean, but you have to have subject ID in this table. But do you need subject, for instance? Think about it.
Now, in order to achieve the normal form, we need to divide the table as shown below. Firstly, let's divide the table and store student ID, student name, subject ID, and address in it. All
because Subject ID is enough to have in this table, but subject itself, you can find the subject, you can find the subject
The columns are
via
referring to
via subject ID, right?
Oh, yes, 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 I see. Okay.
That's why he removed here subject and the new table containing only this. And you will have another table containing only subject ID and the subject.
Yeah.
the primary key, which is student ID. Then the second table have subject ID and subject column. So subject is dependent only on subject ID and not on student ID. As you can see from the above table, all the non-key attributes are now fully functionally dependent only on the primary key. In the first table, columns such as student name, subject ID, and address are only dependent on student ID. In the second table, subject is only dependent on subject ID. With this being understood, now we can proceed further to next normal form, that is voice code normal form. This is also known as 3.5 normal form. It is a higher version of third normal form and was developed by Raymond F. Boyce and Edgar F.
After third normal form, they started with first and second and third, and they started also recently, like other normal forms, they started to have like even four and the five and so on. So it means like when it's possible to like make your table just smaller and smaller, to make the like design of your tables better and better, they started to add like more and more normalization, as you see here.
Code to address certain types of anomalies which were not dealt with third normal form. Before proceeding to Boyce code normal form, the table has to satisfy third normal form. In Boyce code normal form, if every functional dependency, that is A implies B, then A has to be the super key of that particular table. So what is a super key? A super key is a group of single or multiple keys which identifies rows in a table. Let's look at the table to clearly understand Boyce code normal form. In the given table, one student can enroll for multiple subjects. There can be multiple professors teaching one subject. And for each subject, a professor is assigned to the student. These are the necessary conditions of this table. In this table, all the normal forms are satisfied except Boyce code normal form. Why? As you can see that student ID and subject form the primary key, which means that the subject column is prime attribute. But there is one more dependency, that is professor is depending on subject. And when subject is a prime attribute, professor is a non-prime attribute, which is not allowed by Boyce code normal form. Now, in order to satisfy the Boyce code normal form, we will be dividing the table into two parts. The table at the top will hold student ID, which already exists, and we will create a new column, that is professor ID. And in the second table, which is below, we'll have the columns professor ID, professor, and subject columns. Why do we need to have a new column, that is professor ID? By doing this, we are removing the non-prime attributes functional dependency. In the second table, professor ID will be the super key of that table and remaining column will be functionally dependent on it. By doing this, we are satisfying Boyce code normal form. So this brings us to the end of this session. I hope you have clearly understood the norm.
So first normal form, or we are like our target to have atomic attribute values, primary case. And then if you are satisfied with I mean, I just also wanted to say, okay, what does it mean, atomic or single value? As I said in the first lecture, if you remember or recall, atomic attributes is always represented by a single value or particular entity. For example, personal is marital status, like, or person is gender, like male or female. You can't decompose this value. So this is like, as we talked about the first normalization form, and in the video also, he showed us like if the column or the student has more than phone number in the same place, how we just decrease this and remove this to have atomic attributes values. And then we went to second normal form. First, to go to second normal form, there are conditions. First condition, you have already first normal form applied, and then none no non-k attributes is identified by the part of the primary k, like the department, from the employee. Like if you have in the table employee id, and then department id, and then department, in this case it's no non-k attribute identified by the part of the primary key. And then the third normal form, as we watched it in the video, like there was like the subject. So in the third, we have conditions for the third normal form as well. In the third normal form, we already satisfied the second normal form, and no non-k attributes is identified by another non-k attributes, as we watched it also in the video. We have here a question from Torlak. Uh, is there any tool in MySQL to normalize the database, or we need to do it with eye inspection? No, to do that normalization, you need, as I told you, you need to work on the design, to draw that with your eye, as you mentioned here, to draw that on paper, or on application. I told you like the name of application. Like you can use something like called eDraw Max. With this like this kind of applications, there are many applications like that. You can use these applications to work on this, to normalize the data, and this requires experience. But in MySQL and this kind of application, this is how to retrieve data, to get data and edit and alter on the data. And also back to your question, I was not sure if it's related only to the point we were talking about or not. If you're talking also about none, because there is also another concept in it's called not only SQL databases. We will study that later. So there is something very important to know. I will just a second. I will explain to you. So, if it's very important, I will put the answer in chat so you can also read that later. So, we have two concepts for the relations in databases in general, or the data. Like, for you have something called relational database. It means that you have connections and the relations between the tables and each other. And you can have something called a non-relational database. This, if you ask about this is the answer. Like if you're talking about this non-relational database, this is the complete question like this. If you mean a non-relational database, in this case you have documents, and in these documents in your computer, in these documents you have a lot of data, but you don't make connections or tables or relationships between this data, right? In that case, we call this a non-relational database, and we will study this still in this course. We will clarify better this document database. There is something called document database, and not only SQL database, and how we can work with data coming from many resources, different resources. Is it like making sense to make relationships and make them like small tables and work on that? Or if you get like millions of records from videos, photos, and the many non-related database, how you work on that, this is something else. because you need to understand the difference between relational database and how it's structured and a non-relational database, and we call it and semi-structured or unstructured. If you mean this question, this is the answer. Okay, and regarding working on normalization, you need to draw them. You need to draw these tables, and then in the MySQL, in this tool, in the tool MySQL, you need to just create the tables, the creation, the building. When you start to build the physical stuff, okay. So here also in this video, it's a little bit also more information. I hope you can see my screen.
No, not right now. Your screen is not.
Really?
No,
Okay.
no.
I have to share it again. Okay. So hope you can. Brand, is it clear for you, this normalization?
And the norm.
Yes, but I think I have to repeat it several times.
You have to do it
for
a lot of
myself.
times. Yes.
It's not that easy.
No. I mean, usually, not every database developer can do that. It requires a lot of experience and
Okay.
a lot of experience and like having the feeling, trying things. So that's why normalization also not every database developer doing it. You can
Mm,
see many application in companies still don't have the perfect normalization. By the way.
Okay. So what is the questions that is coming up for me when we look at the steps we saw in the video and you explained to normalize a database? Mm, there was also always the need that there are some data in the table. So if you have completely empty tables, you are not able to normalize because the reason for normalization depends on the real data that are in the tables. Is this correct or is this wrong?
No, it's not exactly like this. The main target of normalization to have less null. Like as you also as you also saw in the video, like if you have many nulls, like if you still don't have department, okay,
Yeah.
and you have like all employees still in like in general, and the department name is null, and you repeat this in like thousand rows,
Mm-hmm.
thousand entries in the database. This makes like the database not normalized and not in the better form. But what if I say, okay, all these employees in a department ID, and I put this like the only ID, and in the another table I have this only one entry for this department. Instead
Okay.
of writing the text about like null, or the name of the department, I just say, okay, this is like production department, and I repeat this with like many entries. In this case, you will have either null many times, okay, but what if you have also the value? Like if you repeat the value, like if you say all of these employees belonging to this department, like you have in the table like department production, and you repeat this in all rows, like in
Mm-hmm.
all rows you have the repeated value. Is it making sense for you, like to repeat the same value many times? Or you can just say, okay, the ID number, and then you can look for the ID number and you can know the name of the department.
Yeah. Yeah. Okay.
Yeah, so it's starting making sense for you when you have like having this in like many times, like when you started to see many examples, like in real examples, and you started to say, okay, many repeating data is not good, and also many null not good.
Yeah,
So
of course.
how you solve this? You start to make all the columns depending on the primary key. In
Yeah,
that case, you have a small table. Sometimes, as you saw in the video, you have a table with two columns, right? You can have like one column called the subject ID and the subject name.
yeah.
In that case, you have smaller tables. So the main idea of normalization, we try to make the tables smaller. So if you have column not depending on the primary key, we try to just put it in another table, in a new table, and
Yeah.
this new table can be related to that table via primary key or foreign key.
Okay.
So is it getting now better for you?
Yeah. Okay. So the main reason is to avoid duplicates.
Exactly. Avoid duplications, avoid
Yeah.
nulls, and so
Yeah.
on. And
Yeah. Now it comes clear.
yeah, and also with this video, it's also giving more information again.
Okay.
I hope you can see my screen again.
Yes. Yes. Yes.
Okay.
Forms. Database normalization is an essential recurrent process in the design of databases. Normalization allows us to avoid what is known as database anomalies. To understand anomalies, let us check this example. Here is a simple table that contains data about orders. Now, if we want to enter an order handled by a new representative, let us say R6. The issue here is that we do not even have the data of the local office and main branch. The person responsible for maintaining the order table does not necessarily have this data. To solve this kind of issue, we need to normalize our tables. Normalization is based mainly on the concept of functional dependencies. An attribute A depends functionally or is determined by an attribute B if and only if for each value of B there is at most one matching value of A. Often, an acceptable database has all its tables in 3NF or in the third normal form. For a table to be in 1NF, it must have a primary key and the contents of all its cells must be atomic. For a table to be in 2NF, it must first be in 1NF and all its non-key attributes must depend on the entire primary key. This means that a table in 1NF with a non-composite primary key is by default in 2NF. In this example, you can see that D, a non-key attribute, depends only on P, which is part of the composite primary key A and B, which means that this table is not in 2NF. To put this table in 2NF, it should be split into two tables. One with B as primary key, D is the other column, and the other table is the original table after removing D from it. And for a table to be in 3NF, it should be in 2NF, and no non-key attribute is determined by another non-key attribute. In this example, you can see that D, a non-key attribute, is determined by C, which is a non-key attribute too. Again, here, we split the table into two tables as shown to put it in 3NF.
Hey, this was a good example.
Yeah.
It was a good example for me. Yes. Okay.
Yeah. So what is the okay? Sure. Just a second. I wanted to also send something here. So this is also explanation better. I wanted to tell you also. So this is also was one question about the chain notation. As I told you, I didn't remember this word only diamond. It's a diamond. In chain notation, we have or connecting or drawing. As I told you, it's just representing. Like it's like different schools for design. So we have chain notation. They use diamond and connecting lines with symbols to describe relationships. So it's very important to know or to define which school of design school you will follow. If you want to follow chain notation, then use diamond, but please keep like the same style always all the time. Like if you joining a company, you have to define which design you will follow. That's very important. Can you see still my screen? Like
Yes,
the
yes,
presentation?
yes.
Okay,
It's
so
the text.
so
Yes, I
today,
see.
first part of the day, we went from our lecture, we wanted to understand design a database using an ERD, model relationships among the tables with an ERD, normalize the tables in a database. This is like the most important one, how to normalize the tables in database. To understand this, you have to watch many and many examples because this requires really experience until you reach like the best form for from normalization. Unit 4, we have here some goals for the unit 4. It's also conceptual. It's not practical, it's more conceptual. So it's also design database through standard processes, convert a conceptual design model into a physical model, use SQL to define a database table. So graphical notations or like and also of entities and the attributes usually start with first thing. We start to identify our tables or entities. We call our tables entities. So we first of all we identify our entities, define relationships, like just measure the same thing when you build a house. You say, okay, how many rooms you need? Like I need like 3 rooms apartment. It means I need like 1 room like for sleeping, 1 room for. So in this case, we identify like our entities, then define relationships between entities. This is like regarding your question, Torlak. You are asking about like, is it something on in like MySQL tool or what? No, it's more about like you start to identify entities, define relationship. All of this, it's still graphical. You still design like your database. Determine primary key, determine primary key, conversion into a physical database model. This after finishing this, we start to go now to physical data model. In physical data model, we started to define and normalize attributes, determine consistency condition, formulate transactions. This is how we start until we end with like now we have our own design, and then we take this and build our own database based on that.
Relational database design and development. Databases as complex engineering systems require rigorous design and development processes. Everything starts as an idea. The idea is initiated by a business or a market need. The path between starting with an abstract concept until the implementation of a final product that end customers can use is long and complex. The good news is that some best practices or rules govern the design, development, and implementation of databases. A database design project starts by gathering the requirements. Simply, we can define this step as the negotiations and discussions between the business or the client and the designer in order to technically define the client's requirements. Once this is done, the design phase can start. In this step, the design phase, we can work on a high-level ERD and normalization. The outcome of this phase is a DBMS independent model, which we call a logical model. Once the logical model is approved, we can move to the next phase, which is the creation of the physical model. We call this model physical because it is DBMS dependent. This means that we will add to the design some specifications that differ from one DBMS to another. For example, the names of the data types provided by different DBMSs are not the same. For example, the integer type is called number in Oracle DBMS and int in MariaDB, among other integer types actually in MariaDB. The final phase is the actual programming, or in other words, converting the physical model to a code written for a specific DBMS and then storing the database on a server that hosts the database and allows the users to access it, usually a graphical interface application.
As you watched in the video now, like we have first, as I told you, like we have like first the design. We come out with the design to physical, start to define if it's integer, is it text, so it's a char, what data type, so use what kind of data types, and we will go also through the data types what we have and so on. So first of all, you have the design, and then you finish with the design, you go to physical, define data types and so on, and then you start to give access. After that, you give access to your data entry or your customers to enter the data in your database. So it's more conceptual. So from conceptual design, we like conceptual data model, like you have the content or attributes for every table or entity, and then you go, if you look here, you go to next step, which is physical data model, and then you have something called the customer ID, a customer number. In this, every one of these, you start to define if it's like this one would be like integer, this one should be like a string. It's based on the database management system that you use, as you watch it in the video. So it's like physical, conceptual, physical, and in this case, in physical, we start more to like understand the data which will be there in the physical in the physical in the physical mode. Yeah, it's a kind of the same. Like we started to define like is it like data, is it like stars, anything accepting what kind of data it will be expecting. Like if for rating, for instance, like for rating here, in the conceptual data model we just have like date, stars, text. In the physical data model, we start to define more. Okay, this is like uh, rating ID, it's ID, you have date, you have stars, you have text, you have customer ID, which is foreign key, and then in the design, after the design, when you start to work with the database, you start to define, okay, if you create the table in database management system tool, you will find this different data types. You will start to define what kind of data types for every attribute you have. Yeah, and also here it's also continue with like from conceptual data, if like the attributes contains, because for every attributes it could contain or have, it contains another, like contains a value or have a value. This is also something also here as definition or conception, concept. You will understand this in better way when you start to build the database. So I want to from you at the end of this lecture, I will show you like a simple code to create database, and then you can just create your own database and start to work around that, like to make the or think about the problem or issue and started to build this issue with specific requirements, to start to make it from design, from logical design, and then start to implement it to enter data from data or from user perspective.
Logical database design. Logical database design must result in a DBMS independent model. This is a waterfall database design methodology. In reality, database design is not linear as in the waterfall process, but this is still a simple approach that can be adapted according to different business requirements and constraints. The most crucial possible adaptation is the possibility of getting back to a previous step to correct an error or solve an issue. Also, notice that the order of the steps is flexible. The process starts by identifying the entities in the database. These are the uniquely identified trackable classes, such as main branches, orders, students, movies, etc. Once the entities are identified, the relationships can be defined. This presents the connections among the different tables. These are created depending directly on the business rules. Then we start by defining the primary key of each table. These are the attributes that will determine all the other attributes in each table. Remember that these could be surrogate keys. Next, we need to create the physical data model, which consists of defining the types of relationships, and these should be consistent with the DBMS that we will be using. And here, we add the attributes of each table. And then we end by adding the database constraints, such as the minimum cardinalities and relational integrity constraints. Finally, we create the queries required for the database's correct and consistent functionality. The physical database model. The physical database model is a DBMS-dependent model. The logical model is DBMS independent. In other words, it is a correct model no matter which DBMS will be chosen to implement the database later. Once the logical model is approved, we need to build the physical model. The most crucial difference between the logical and physical models is that we model the relationships in the physical model. There are mainly three types of relationships: one-to-one, one-to-many, and many-to-many relationships. Modeling and creating relationships relationships are realized by inserting the primary key of one table in another. For example, in a one-to-one relationship, we can insert no matter which primary key from one table into the other. In a one-to-many relationship, we call the table on the one side the parent and the table on the many side a child. And the relationship is created by inserting the primary key of the parent in the child table. And it will be called in the table, in that table, the child table, a foreign key. Many-to-many relationships cannot be implemented directly in most DBMSs. This is why we need to break many-to-many relationships into two one-to-many relationships using a relationship table. In addition, we need to model the minimum cardinalities in the physical model. Minimum cardinalities can have the values of mandatory or optional. These are realized within the physical model as different DBMSs enforce minimum cardinalities differently.
So now we will go through data types, like in like character string was always exactly in characters. If you wanted to write string or give like name and so on, you can like use like character or char as alternative, or character. It's based on the database management system that you use. So like it can contain examples like country code, like Deutschland and France and Netherlands and so on. This is how you like add like characters. It can take also ISBN numbers, 13 numbers, and so on. This kind of example. So you need to know or to understand what kind of data you will be expecting in this data entry before you start building your database. Character string, in this it expecting more characters. So in this case we define something called varchar, or you can find something called also character, or it can expect, like you can change this. It's like how many letters you want to allow the user to enter. So you can also change this value, and also it's based on the database management system that you use, the tool that you use. It can take names of users, uh, designations, short description if you want. Like you can also use something like varchar 55. So in this case, you expect a 55 letter, or you can change it to 160. So in this case, you expect like more, or you can even increase this number to expect more characters when you enter the data. Very long character in this data format or data type. You have you can select something like text. In tickets it's like more description, or you add more data as data entry. So you need also like to define what kind of what is the reason to add like it's very long. Maybe it's like description, maybe it's like paragraph, whatever, how it's like your database based. So you have to understand what you really need. Integers, it's a 32 bits value, range from -2 up to this big number. It's like 2 billion, 2 billion something. So it's like very like if you need like number in this range, if you need to allow any number from this range, you can find it's integer or int, just int in like in Maria database, or like you have really to, or int also in like in SQL Server from Microsoft. Examples like numbers, index, numbering, and so on. Decimal numbers, it's the data type, it's decimal. It's used with a maximum of number digits in total and exactly m digits after the decimal point. So this is for amount of like money, like if the data you are entering like amount of money, so you can select data type of decimal. Floating point numbers, if you have like floating, you can use real SQL for SQL data type real, and in this case it's measured value for floating point if you have floating point numbers. There is also a calendar data type. This is calendar data accurate to the day from year like 1000 to year like any year. If you want to add a calendar data type like a date or like calendar days, you can use date. There is something called the time. This is in hours, minutes, seconds format. You can use SQL data type time. There is also another data type called the timestamp, which is bringing this together, like the date and the time together. Like, but it's mostly used for like to get the timestamp of transactions, time steps of transfer something to another, and so on. This is exact determination of a time, exact to second, often in the format years, months, day, hour, minutes, seconds. And it's automatic saving of creation or modification time. You can use this to like if transaction happening, you just get the timestamp from the like database, the PC. You can just get the timestamp from the device, which is or the computer which database running on. We have like var binary types with variable lengths, but not more than n characters, n bits. This is if you want to store binary data such as image. Usually with this we use this kind of this var binary for saving images, videos in the database. Boolean value, and also sometimes you face like problems when you try to like enter big image. Usually they define this like with this number, so how big you need to like how big the image or the audio or the video should be. You can use also this data type, or and also with this varying, so how big should be the file. Boolean values, it's true or false. It like Boolean. This is the SQL data type, and this is Boolean values. And I also told you that like it's very important to start to create your own database. Like this is the code. If you wanted to create database with code, you can just give sorry, you can just use create and give database name first. If you want to create database, it will be create and the database name, uh, and then you can start creating your tables. Like if you want to create table, you can just write create table, and you give the name of the table. You can just give the table name like customer, department, or whatever, and then you give like the column definition, like primary key definition, uh, integrity rules. It's like information about the attributes for this table. or you can easily create the table from database management system by wizard form. So you can just select table, create new table, and so on, it's based on the tool you use. But you can also do that using like the code like this, and we can also define what you need there. Okay, so today we wanted to, like in the new unit 4, we wanted to design database through standard processes, convert a conceptual design model into a physical model using SQL to define database. Now we go through the transfer task. So the transfer task, you get giving the following branch table. Try to first normalize the above table by putting it in the third normal form. Can you see still my screen? Brand, can you see my screen?
No, it disappeared a few for some few seconds. It
Okay,
disappeared.
now?
Not no, right now. Not. No.
That's,
No.
okay, just a second.
Only the participants, but not your screen.
Okay. Can you see it now?
Ah, now it comes up. Yes, right now it came up.
Okay, so this is the task for next time. So giving the following branch table, you have this table. It's a very important task to understand the normalization. You still see my screen, right? Can you still see my screen?
Yeah, it's okay.
Okay,
See?
so draw the ARD of the normalized tables. Write the SQL code that create normalized table. After, like you take the conceptual design, work on the conceptual design, and then you start to transfer this to physical ones. This is the task. Please,
Okay.
please work on it. Here also, as you see here, you have like employee and department and branch. Employee like has like employee integer, department branch, and so on. So we need to like you need to represent like here, like if you want to make this, like here you have here employee, and this is attributes of employee. You have department, this connection between them. Okay, what is the question here? Okay. So this is like here just some information to solve this, some more information to solve this issue,
Mm-hmm.
task that you have. Okay, and then you will present this the results next time. Okay, now this is like the most important part from the lecture, to know from you if like you understood the main topics or the conceptual topics or not. What is the graphical representation of a database design called? Microsoft Access, Easy Design, QPE, ERD. ERD.
It's the
Yeah. Uh, okay. Just a second. I just want to. Okay. So, what does normalization mean? Is it remove as much data redundancy on the table level, or add as much data redundancy, remove as much data redundancy to allow data anomalies, add as much data redundancy on the table? Which one? What do you think? Brand, you wrote A.
Yeah.
Yeah, it's so the what does it mean normalization? To remove as much data redundancy on the table level to avoid data anomalies. So you don't need to allow data. That's why we didn't select C, because we don't need to allow data anomalies or nulls. It doesn't make sense. What is the particularity of varchar look data types? What is the particularity? Like data occupies more memory when it's longer than the defined length. Data occupies less memory when it's longer than the defined length. Data occupies less memory when it's shorter the defined length. It's C, because this is something you need to know. Varchar is a good thing if you like defined varchar like this, and you wrote only like letters or something, or small, just something like this. In this case, it will take less memory from the when you work on the database. It will take less memory. Why? Because it's defined like to use based on the data entry. And that's why varchar is very good to use. That's it
So,
for today.
so varchar, the memory for a varchar is not pre-allocated, is that right?
Yeah. I mean, it's based on like like it's trying to take like less memory, because it's try to take the length based on
Okay.
the entry you add.
Once you have designed the table in a physical system and you want to enlarge a varchar, is this possible while data are on a table?
Yes, it's a possible. It's a possible to once you started already, it's possible to enlarge that. It's okay. It's possible
Ah,
to.
okay, okay.
But the main idea, what's not good to have like to break the tables after you built them. That's why we talked about this normalization. It's better to draw that first and then start to build the physical one in the data in DBMS. Like you go to DBMS when you have the full design, the full relationships, and then you start to build that, because it doesn't make a lot of sense when you like built the tables and then you start to break them down again, right?
Okay.
That's why it's very important to work on the design concept, or the like logical concept, before you start to go to physical. That's it for today. I think we have the next time on Monday. I wish you happy weekend and see you on Monday. Bye
Thanks
bye.
a lot for you too. Bye bye.
Thank you. Bye bye.